Hi guys, this is Mike, and I am coming at you today with video investigation number 3, discussing how do landscapes change. So while we're looking at the process of how landscapes change, we have to ask ourselves the question, why is weathering and erosion so important? And in the image here, I've examples of both, and I'll get into that. But basically, the subtext of it behind it is weathering and erosion are vital because, um, as we have on the continent, these structures that we see and that we walk on and point out, like the mountain in the background here, um, these structures and the textures, they don't stay the same forever, as we've learned throughout the course of this class. We've got stuff going on in the plates below us. They're colliding, diverging, creating volcanic activity, and we separate weathering and erosion with the two principles of whether it's chemical weathering and whether it's physical weathering. Now, both of these concepts start with the rock cycle. So I'm going to first go ahead and talk about this red section here, which really breaks down chemical weathering. And it's caused by, basically the convection cycle. Like when I was with in Ms. Silvester's class last semester, she always used the example of a lava lamp. So we've got, basically you got igneous rocks that are on top, but they're constantly going through this cycle of weathering, transportation, deposition, sediment. They're sedimentary rocks, and then they go through metamorphism, which is getting subducted down into the ground, whether they're being subducted or dissolved through collision or divergence, and they're coming back up in this constant rock cycle. It's why we took elements in video investigation number 2 and picked apart and constructed the different elements where we found metamorphic rocks. It makes new structures. So while we have structures changing due to collision or divergence and convergence, but we also have new structures being added onto our lithosphere and our crust constantly. And one of the really good examples of chemical weathering that I found fascinating, and I think there's the closest example would be Carlsbad, but we have Carvernius taverns, and this is dissolved limestone once it hits water vapor and carbon dioxide. And it's fascinating as much as it is sort of terrifying, because as you know, above this is where we're standing, and when this material dissolves more and more and these stalagmites get weaker and weaker, it collapses, and we get sinkholes, landslides, and mass movements, which we'll also get into with the brief amount of time we have. And like I said, this top part would be the physical weathering. So you've got your igneous rocks that have come up through the ground, and then through the process of weathering, whether it's rain, oxidation, wind, sediment being transported, all this stuff, it makes up the surface of what we're able to visually see right here. Now, moving on, a good example of that would be freezing and thawing, and specifically ice wedging. So, here we have the mechanical weathering, which was, shown up here. Mechanical weathering and physical weathering can be substituted for one another. And when we have water freeze into a crack, it expands and makes the rock bigger, and sometimes it can create these striations, or also we have these rocks that just split apart completely. And obviously this is a smaller rock, but if you compare it to a mountain like this, yeah, that would create a pretty massive change. When we were asked to give an example of which type of glacier do we think would change the landscape more, I immediately thought of the Matterhorn in Switzerland, and specifically kind of the pyramidic scheme of it. And I have this slide referenced here. I did not make it. It is at the end of the presentation, obviously, but we have these pyramidal peaks. So the Matterhorn up top here didn't always look like that. But what we had is we had an errate form when we had two other glaciers collide towards each other, and the two back walls came together and they formed these sharp edges. And when three or more krais rode together, we had this sharp incline. And the most famous example, which I believe we have Dr. Wilson visiting this summer, I think she mentioned that. We get famous example of the pyramidal peak, the Matterhorn. It's also a ride at Disneyland, but the actual peak is in Switzerland. And then, so, when we're talking about mass wasting and what is most detrimental, I took Mrs. Ivester's natural disasters class last semester. I immediately knew, landslides. And what I found fascinating, though, was we did not talk about the Uttarakhand landslide in 2013 or 2014. A lot of lack of information from the Indian government on how this happened and what went down. But in 2013, we had about 5,700 people in this Himalayan state on the Indian continent suffered death, injury, property loss. And through the environmentalists and scientists and the government basically came out and said was that they admitted that they were not consistently checking the structures, checking the porosity and permeability of the soils. And when we experienced heavy rainfall in this area, people lost their homes and people lost their lives. And when we take this to the desert, I think I find the abrasion we find in the desert fascinating because you'd immediately think that it's chemical weathering, but it's not actually. It's mechanical weathering, and this slide also referenced in the last slide of my presentation explains how basically we have sandblasting a desert, we have wind, oxidation. Not oxidation, I apologize, I misspoke. Oxidation would be chemical. But we have just rocks hitting other rocks, and we have these really cool features that come of it. Yeah, it's basically mechanical weathering, sort of in a weird way. You would think it's chemical at first, and I think it's why I found it so fascinating. And then we have my reference is right here. Now, the last question 7 asks us, what agent of change do we think will create the most change over time? And I think it ultimately, we could talk about glaciers, we could talk about the erosion. However, when we, subsurface right below our feet, we talk about, global warming, the convection cycle. The Earth we're only getting warmer. And when that happens, we're going to have more water vapor and more carbon dioxide dissolving, not just limestone, but eventually we'll find more minerals and metamorphic elements. And, thinking about the ground beneath us just someday falling out is terrifying, more so than a tsunami or even a landslide. I feel like I learned too much about what not to do in the natural disasters and environmental studies course last semester, never to put myself in a compromising position for landslides. So there is the quickest way I could get through the 7 questions, and thank you for your time.